Good morning, Year 9. This is Mr. Essa. Today, we are going to discuss some questions for work, power, and energy. Our lesson objective: apply the concepts of work, power, and energy in answering questions. Success criteria: I can use the formulas related to work, power, and energy in answering questions. Here are the formulas that we need for this task for today. We have formula for work. Work is equal to F times D, and work is equal to F into H. Power is equal to work divided by time. Energy. Kinetic energy is equal to half mv squared. Gravitational potential energy is equal to mgh. Gravitational potential energy lost is equal to kinetic energy gained, and gravitational potential energy at the top is equal to kinetic energy at the bottom. We have to bear in mind though that this work is done against gravity. This work formula is done when the work is horizontal. And for power, we can apply any of these work formulas for work divided by time. And for work done against gravity, work is equal to F into H. In this case, F is equal to mass into the gravitational field strength, mg. Therefore, we can also say that work here is equal to mgh. And if you will compare it, it's like similar to gravitational potential energy. Okay, let's start with our first problem. Figure 2.1 shows a rock that is falling from the top of a cliff into the river below. The mass of the rock is 75 kilograms. The acceleration of free fall is 10 meters per second squared. Calculate the weight of the rock for the first question. And the rock falls from rest through a distance of 15 meters before it hits the water. Calculate its kinetic energy just before hitting the water. Show your working. So in this case, you first have to look at your given. We have 75 kilogram, which is in its proper SI unit. 10 meters per second squared, which is also G. Now you have to remember G can be 10 Newton per kilogram. This is the gravitational field strength. Or G is equal to 10 meters per second squared, which is acceleration due to gravity or acceleration of free fall as discussed in this problem. Now 15 meters here is also in its proper SI unit, so no need for conversions. This is quite straightforward question. Okay, let's start with question letter A. So for question letter A, the mass is given. Mass is equal to 75 kilogram, and it's asking you to calculate the weight of the rock. So this is quite easy. Weight, we know that weight is equal to mass into acceleration due to gravity. So therefore we have 75 times 10, which is the acceleration due to gravity. Therefore our answer for the weight is 750, and the SI unit is Newton. Why is it in Newton? Because weight is a type of force which is acting downwards. So the first question. Move on to question letter B. Question letter B asks you to calculate the kinetic energy just before hitting the water and show your working. Yesterday we discussed for question letter B here, okay, we know that PE, gravitational potential energy, GPE lost, will be converted into kinetic energy. Okay, so gravitational potential energy is equal to mgh, we know that. Therefore, we are going to calculate m is 75 times 10, which is the acceleration of free fall, times the height it traveled is 15. Okay, so if you are going to calculate all of these together, multiplying these numbers to each other, then you are going to get 11,250. And do not forget the SI unit, joules. This is the final answer for letter B. Usually this is 2 marks, one mark for the working, 1 mark for the final answer. Now the final answer should always have an SI unit. So that's it for this problem. Okay, let's move on to our second question. My advice, you pause the video, work the problems out for yourself, and compare your final answer to my answer later on. Okay, a student wishes to work out how much power she uses to lift her body when climbing a flight of stairs. Her body mass is 60 kilograms and the vertical height of the stairs is 3.0 meters. She takes 12 seconds to walk up the stairs. So all the given are in their proper SI units. No need for conversion. Calculate the work done in raising her body mass as she climbs the stairs and the output power she develops when raising her body mass. So in here we need work done, which is this kind of work is work done against gravity. Therefore, work is equal to mgh, where mg is the force. Okay, and then output power, the power formula that we need is equal to work divided by time. Okay, so let's work out A1 first. We know that work in here is equal to m times g times h. M is 60 kilogram over here, 60 times gravitational field strength is 10, and then h given here is 3. Okay, so 60 times 10 times 3, we will be able to get 1,800 joules. If you answered 1,800 Newton meter, this is also accepted. It's fine. Usually this is just one mark question. Okay, let's move on to the second one. A2. So A2, we said earlier that power is equal to work divided by time, and the work done that we solved earlier for A1 is 1,800 joules, if I'm not mistaken. So now we're going to solve for power. Power now is equal to work divided by time. Okay, the time given here is 12 seconds, so work is equal to 1,800 divided by time, which is 12 seconds. So if we are going to divide that, we will get 150, and the SI unit for power is watt. But if you answered 150 joule per second, that's also accepted. 150 joule per second, that's also accepted. So that's the answer for A2. Let's move on to question letter B. At the top of the stairs, she has gravitational potential energy. Describe the energy transformations taking place as she walks back down the stairs and stops at the bottom. I haven't discussed energy transformations yet for you, but I've already discussed the different forms of energy. Now we know that if work is done, transformation of energy is taking place. In this case, if she goes down the stairs, then her GPE, gravitational potential energy, decreases. That will be transformed. That form of energy will be transformed to other forms. In this case, she's walking, therefore one transformation will be into heat. Okay, other transformation will be into sound. This is not yet important for you to answer because we have not discussed this part yet. Although if you already know, then that's fine. This is a 2-mark question because you have to mention that GPE decreases as she goes down the stairs, but the transformation will be from GPE to heat and sound. Okay, moving on to question number 3, our practice question. A farmer uses an electric pump to raise water from a river in order to fill the irrigation channels that keep the soil in his fields moist. So this is our figure 5.1. It looks complicated, but actually if you already know your formula and you practiced enough, this is quite easy. Every minute, the pump raises 12 kilograms of water through a vertical height of 3 meters. So you have your mass and you have your height. So this is work done against gravity also. Calculate the increase in the gravitational potential energy of 12 kilograms of water when it is raised 3 meters. So we are asked 2, solve for the increase in gravitational potential energy. So this is quite easy. For letter A, we are just going to calculate for GPE. GPE formula is mgh. We already know that m is 12 according to the problem, 12 kilograms times gravitational potential energy is, gravitational field strength is 10, and times the height is 3 meters, so 3. So calculating, we will get 360 joules. This is 3 marks. Why is it 3 marks? So you will be given a mark for the formula in this case, the working, and then the answer, and then SI unit is very important. Okay, letter B. For letter B, we are asked to calculate the useful power output of the pump as it raises the water. So power here is equal to work divided by time. Okay, the work or energy in this case is already worked out, which is 360 joules. So work now is equal to 360 divided by time. What time are we talking about? In this case, it's 1 minute. So 1 minute is 60 seconds. So we're going to divide it by 60. So the final answer for this 360 divided by 60 will be 6. Okay, here I will put the answer here because there's no space over there. 6, and joule per second is fine, or 6 watt. So this is the answer for this problem. Now here are the problems that you're going to work out individually. I am going to send you a copy of these problems also in our meeting chat, so that you won't need to pause the video for a long time. And for work number 1, this is your problem and figure. For number 2 and number 3. Now all of these have like complicated figures, but actually you just look into the questions themselves, and if you know your formulas, there won't be any problem. So in here, let's say for example here, the first problem, you're being asked of increase in PE and power. This was similar to the previous question, the third question that we have just solved, so it's easy. And you look at your givens, 36 kilogram, 2.4 meters, so that's quite easy. No conversions needed. Here also is 2.4 meters and 4.4 seconds for your power. It's already in seconds and in meters, and you just have to work out which work are you going to use for the power formula. Okay, so the second question that you're going to work on by yourself independently is also potential energy. So potential energy, you already know the formula. GP is equal to mgh. You have your height over there, you have your mass, and you always have to ask yourself, why is mass given? What will I do with it? What formula am I going to use involving mass? And then speed over here, why is there speed? Okay, so you have to remember that kinetic energy is equal to half mv squared. There is speed formula over here. By manipulating this formula itself, you'll be able to find the speed of whatever you're solving for, speed of water in this case. And you know that GPE lost is equal to KE gained, so you are going to use that too. And letter C is suggestion. So this is quite different for you. Now the third part of the question is the vertical speed of the water is less than the calculated. This is an explanation question. Some of you are very weak in explanation answers. You tend to use a lot of words in explaining. If it's just a 1 mark question, we need a straightforward answer only. So you don't need to use a lot of words for this. You have to be concise, and you have to use the exact words that we're looking for. Okay, so just one reason for this. You have to find out the words. You have to write your answers in your notebooks. Okay, third question for your work, individual work, is this one. So now don't be nervous if you will see some figures like this. It's easy, okay? So 0.60 kilogram is given. You have a distance of 0.90, and you're going to calculate decrease in GPE. Okay, GPE is equal to mgh. You don't forget that. And the ball hits the ground at 7.0 meters per second. Calculate the initial energy given, and ke here is equal to half mv squared, because you have 7.0 meter per second as given. You can use that, and it's a 3-mark question. You have to remember your marks also. It means that everything will be checked, your working, your final answer, the SI unit. So that's it. You're going to write your answers in your notebook, and then we're going to discuss in class the answers for these questions, which is all about work, power, and energy. Okay, so what have we learned today? We learned to use the formulas related to work, power, and energy in answering questions. So I hope you enjoyed the lesson. This is Miss Teresa signing off. Have a nice day.